Hello. All right, we're going to continue our work in Unit 6. This is going to be focused on inverse relations. An inverse relation interchanges the input and output values of the original relation. So what that means is that if my that's not even close. If I had something like, okay, I've got my x's and I've got my y's. Say I have 0, 1, 2, 3, and 4. And then my y's go 6, 4, 2, 0, -2. The inverse of this function is going to flip-flop my x's and my y's. So my x's are going to go 6, 4, 2, 0, -2. And my y's are going to go 0, 1, 2, 3, 4. So you can kind of see that, again, what did we do is we took our x's and they became our y's. And then we took our y's and they became our x's. So what that looks like in like an example is if we have the equation y equals 3x minus 5, and I want to find the inverse, what I'm going to do is I'm going to go, okay, y, so what I'm going to take my original, problem, but I'm going to flip-flop. Oh, it's a picture, can't do that. I'm going to change where I put my x's and my y's. So I'm going to swap these two out. So if I rewrite it, it's going to be x equals 3y minus 5. But again, we don't like having our equation as x equals. So we're still going to set it up how we like it with y as a y equals. So again, I can just put the y on the other side, but y equals x plus 5 over 3. So that's going to be my inverse. Another way you could write that is as x over 3 plus 5 over 3. Again, just different ways to write the same thing. So kind of like one of the key concepts is, again, functions f and g are inverses of each other if f of g of x equals x and g of f of x equals x. So you have an inverse if this is true. If these two things are true, then you have an inverse function. And if we ever see something like this, you can read this as f inverse. So that's another way that you'll see it. So let's say that you have two different functions and you need to prove or show that they actually are inverses. So let's take our function f of x equals 3x minus 5, and then we'll take f inverse of x and call that 1/3 x plus 5/3. So again, to verify or show it, what we would do is we would say, okay, I'm going to show that f of f inverse equals x, and I'm going to show that f inverse of f equals x as well. So I'm going to take my function f, but every time I do that, I'm going to write the inverse. So again, the two things we're looking at is here's function 1, here's function 2. It's just like what we learned last lesson with composites. Every time I see f inverse, I'm going to write 1/3 x plus 5/3. So 1/3 x plus 5/3. But now I have to account for my f that's out here So now I'm going to rewrite it and say, okay, every time I plug in or I see an x, I'm going to write 1/3 x plus 5/3. So it's going to be 3 times 1/3 x plus 5/3 minus 5. 3 divided by 3 is just 1, plus, again, 3 divided by 3 is 1, so I'm just left with 5 minus 5, and 5 minus 5 cancels out, so we just get x. Very similarly, if we look at the other side, okay, I've got f of x. Well, I know that f of x is 3x minus 5. And if I take the f inverse, okay, that's going to be 1/3. Every time I see x, I'm going to write 3x minus 5 plus 5/3. Now, 1/3, 3 divided by 3 is just 1. 5, and this gives me negative 5/3, but then I still have plus 5/3 over here. So you can see that that's going to cancel out, and we are left with x. So you know that that is the correct, that is a true inverse function. So if I ask you to show it, this is what I'm asking you to do. Show me that these two functions are inverses. All right, continuing on, elastic bands can be used in exercise to provide a range of resistance. A band's resistance, R, in pounds, can be modeled by R equals 3/8 L minus 5, where again, R is pounds and L is total length of the band in inches. So first question is find the inverse of the model, and then use the inverse function to find the length at which the band provides 19 pounds of resistance. So again, what I first kind of want to do is I want to eventually get length. So what I'm going to do is I'm going to start by adding 5 to each side. So I'm left with R plus 5 equals 3/8 L. And then again, multiplying by the reciprocal will cancel out. So I'm going to multiply both of these terms by 8/3. So my answer is going to be 8/3 R plus 5 times 8 is 40. And that gives me L. So that's good. That's something that I can work with. And now, because the question asks me, when does the band provide 19 pounds? So I think, all right, is R pounds or is L pounds? And I know that R is pounds. So I'm going to plug in a 19 every time I see R. I still have 40/3 over here, and I'm hoping to find the length. So 8 times 19 is 152. So I have 152/3 plus 40/3 equals L. 152 plus 40, because I have the same denominator, I can add them. And then 192 divided by 3 is 64. L is in inches, so the band will provide 19 pounds of resistance when L is, or when the length is 64. So when we're graphing things, so inverses work like this. So the inverse function follows the line y equals x. So if I just kind of have, plotted points, and I say, hey, if this point is at x is 1, y is 2, or x is -1, y is 2, okay, that would be, however far away it would be from my my y equals x line. So I would say, okay, this is 1, 2, so I would go 1, 2 right here, and then I would have to go down 2 units as well. So this would be my inverse, would be right here between this point and this point, because it follows the line y equals x. But you can also see that with some like non-linear lines. So again, what do I mean? I'll show you a picture, something like this, where we have, let's try that again. we've got these two lines, or these two nonlinear functions that are following the line y equals x. So you can see that the blue on the left side here, the blue is y equals x squared. And then the red one is x equals y squared. And you can see how they kind of relate and follow along this y equals x line. So the inverse always kind of is in relation to the y equals x line. And so one way that you can find this, or you can do this, is we're going to go back to our horizontal line test. Excuse me. We've used the vertical line test before. So to find if an inverse is true or not is if it passes the horizontal line test. So inverse is a function if it passes not the vertical line test, that's for the normal function. So you check the vertical line test for a normal function, and then you check the horizontal line test to see if it passes the inverse function. So if I were to say, okay, the inverse is a function if it were to look something like this. Okay, as I move my line horizontally, I am never touching more than one spot. So this is inverse is a function. Whereas if I just have, say, like a parabola, this inverse is not a function because you can see there are multiple spots that my horizontal line is failing. Inverse, not a function. We can also do this with like exponents. So let's say two more examples here. If we say find the inverse of x squared, then graph f and f inverse. So again, if my original function is f of x equals x squared, I'm going to replace x and y. So I'm going to call this x equals y squared. And then to get y by itself, I need to take the square root. So the inverse of x squared is the square root of x. And remember, square roots have positives and negative values. So if I were to graph it, my x squared graph, and we're just going to keep it on when x is greater than or equal to 0. So again, I don't need to worry about that negative number. But this is my x squared graph. And then my square root graph would look, square root of x would look something like this. And then I'm going to draw in kind of the line y equals x would be right here. So you can see how they kind of relate to each other. Y equals x. All right, and let's do one last example. The average price in dollars for a National Football League ticket can be modeled by the function P equals 35T 0.192, where T is number of years. Since 1995. Can't even read that. And P is the ticket price. So my original function is right here. To start off, I'm going to work in reverse order. So I've got 35 multiplied by t. So to get that out of there, I need to divide both sides by 35. So p over 35 equals t to the 0.192. And what I need to do to kind of counteract this is I'm going to raise each power to the 1 over 0.192. So I'm basically, again, going to try to cancel it out. So if I'm going to raise this to the 1 over 0.192 power, and I'm going to do that same thing over here, 0.192 underneath 1. And the point of doing that is because I get the same thing on the top and the bottom, so it cancels out. So I'm left with T. And if you do 1 divided by 0.192 on your calculator, you end up getting about 5.2. So P over 35 to the 5.2 power. And again, that's kind of a slight rounding approximation, but that's going to be my inverse. Remember, these squiggly lines right here is approximate.